Hello and welcome to this lecture series of normalization. In the previous lectures, we have talked through first to fourth normal form, and in this lecture, we are going to talk about the fifth normal form. The basic prerequisites for a fifth normal form is the table should be in fourth normal form and there should not be a joint dependency. It's also known as project joint normal form. So, if a relation has a joint dependency, then it can be divided into smaller relations such that if we combine those smaller relations, we get the original table. It simply asks that can we decompose the table without the loss of information? Well, let's understand it. Consider a database of library that keeps tracks of books, authors, and publishers. We want to capture the information regarding books, their publishers, and who are their authors. You're also familiar if you have seen the third normal form, as we have seen the similar example in illustrating the third normal form. Every book can be written by one or multiple authors, every author can write multiple books, and every publisher can publish multiple books. Very simply, we can divide the information into three distinct tables or entities, namely book, author, and publisher, as we did earlier. Since book, author, and publisher entities have many-to-many relationships to each other, we can bridge them up by introducing associative entity, here book, author, publisher, which combine the author ID, book ID, and publisher ID to identify a unique record. This structure conforms till fourth normal form. But can we decompose the table further? Or alternatively, we can ask that can we break down this table without any loss of information? Is this table in fifth normal form? The answer is no. The table is not in fifth normal form, and we can still break the table apart. Here, the table book author publisher is split across into two tables, book author and book publisher. So here is the ERD diagram, which you can see. Using SQL joins, we can find the publisher for the book and its authors eventually. So this is just an illustration of how we can decompose a table into two and achieve fifth normal form, although this won't give us much gains in terms of performance. In the next slide, we'll discuss a similar yet different example where we can have associative entity, which is in fifth normal form. Here, let us suppose I am a business and I sell products, I take it from certain vendors, and there are certain customers to my business or to my store. We have three tables, supplier, product, and customers, and we can have a matrix combination depicting which customer buys what product and who is the vendor for that product. Like for the previous example, we might think to disintegrate supplier, product, customer into three different entities like supplier, product, product, customer, and supplier, customer, and then think of combining them from the SQL. So in this example, we have broken it down. Supplier product captures the products and the vendors. Like whatever Dell produces, we can capture this information here. Customer product, whatever the products are being bought by the customer, and supplier customer, which captures the vendor of a product. But after this also, we are not able to establish if Dell sells a keyboard to A, as HP is also supplier of keyboard, and we can never trace back if a customer is buying a keyboard and it is coming from which vendor. And the fact that Dell is bought by A, like here, is true for keyboard as well as mouse. So clearly we can see there's a loss of information that is happening when we decompose into these three entities. All these values must be present together to depict completeness so that we know that Dell makes a keyboard and that keyboard is bought by A. Using this combination, we are not able to establish A bought a keyboard, but from which vendor. Dell makes a keyboard, that's fine, but whom it sells to. And I'm not able to establish, well, A bought something from the Dell, but what was that product? The Cartesian join shown in the previous slide is in fifth normal form, and it does not have a joint dependency. I'm talking about the product, supplier, and customer Cartesian product. Breaking it down into three binary relationships will lead us to loss of information in the database design. So, do not decompose a table if it leads to loss of information or creation of unwanted information. This example might seem similar to the previous one of book author and publisher, but it is different in a way that we have floating combination of supplier, product, and customer. Remember the word floating. In the previous example of the books, the table could be decomposed as book has to have one and more authors. And here, the product can have one or more suppliers. And the suppliers can vary, but the authors do not change and are tied to the book ID. So that is the key difference. So let's summarize the fifth normal form. We break the table down if there is no loss of information and there is no joint dependency. While achieving the fifth normal form, we can improve data consistency and integrity, but it is often difficult to achieve in practice and may not be necessary for all database designs. The decision to aim fifth normal form should be based on specific needs and requirements of the application being developed. Thank you and see you in the next lecture where we summarize all the normal forms.